We're in section 2-5, and I'm looking at page 118. We're going to solve differential equations by using numeric methods again. We're going to solve the exact same problems we did in section 2-4. We're just going to do it different. We're going to use the improved Euler method. Okay, so that is our plan. And in that plan, we have a differential equation, dy dx is equal to some function in x and y. We have an initial position, so we know where we're starting from. And then we're going to calculate a k1, which is going to be the function at x sub n, y sub n. So as we step up, this is going to be 0, 0, and then it's going to be x1, y1, and then x2, y2 as we do these things. We're going to look at some intermediate solution, un plus 1, yn plus whatever the step is, we'll call it h times k1. And then we'll calculate a k2. And that's going to be f of x n plus 1 u n plus 1. And then we're going to find y n plus 1 as yn plus the step h times 1/2 k1 plus k2. So what we're doing is basically cutting the step in half and finding two different points and calculating our answers slightly different. And in this particular case, we should be able to come up with a better answer than we did last time. That's the whole point. Okay, so we'll start with problem number 2. And problem number 2 is y prime is equal to 2y, y at 0 is 1/2, and the analytic solution, y of x, which we're going to compare to, is going to be 1/2 e to the 2x. Okay, so that's the plan. So we'll go up on a spreadsheet for 2. Okay, so this is problem number 2. Here, there's my k1, which is going to be 2 times y, and y is going to be c3. And then there's my un plus 1, yn, c3, the step times k1. Then I'm going to find k2, which is the function of those guys. How come it 2e2? Yes, that's what it would be. It'd be 2e2 because That's to the y guy, and there's the y guy right there. And then we find the last thing, which is yn plus the step times a half times k1 plus k2, k1, k2, and then the real number, 0.5. And we do that 5 times. What are we supposed to be doing here? We're supposed to be going, yeah, the interval is 0 to a half. So there we are, 0 to a half. And so we will go back to that guy and do a copy of him and say we're done. Okay, then we're going to move on to problem number 4. Problem number 4. And in problem number 4, we have y is equal to x minus y. We have y of 0 is 1. And for an answer, we have y of x is equal to 2e to the minus x plus 1 minus 1. And that's not too clear, so we'll make that a little clearer. Okay, now you notice that on my spreadsheet I didn't really have an x, did I? Okay, so we'll come down and we find for number 2, the way we're going to get the x is going a13 times b13. And that's going to give me where my x is. So there's my x minus c, x minus c, x minus c. There's my u of no, okay, yeah, right, times b1, so that's right. And then there's that guy. I want the function at the next value of x, which is going to be 14 times h minus 13e, which is right there, okay? So that guy's right, and here we are finding the last formula we need, and then comparing it against the truth. So there's the truth, 2 exponential minus x, x minus 1. Alright, so we see that if we remember what those numbers were in the last section, we would remember that they are closer to my answer than I had before. So this is a better method. I have a better answer. What more do I want? Okay, we'll look at number 6 next. And in number 6, we want y prime to be minus 2xy. And we want y at 0 to be 2. And we want the real answer to be e to the minus x squared. We're going on an interval of 0 to a half again, and we're using a h of 1/10, in case anybody was wondering. We'll go back to our spreadsheet. And look at the other next guy. And we see that we're very close to the real answer. Exponential minus x squared. Exponential minus x squared. 2 minus 2xy. Again, my x is my A column times my B column. And then, okay, those guys all look good. And we end up, how come this guy's a 0, I wonder? Minus 2 times all those guys. How can that possibly be a 0? A29. Okay, so we need a 6 sitting here so that that's not a 0. There we go, much better. Okay, and again we're closer than the method we had before in the last section, so that's good. And now we'll look at problem number 8. And problem number 8, y prime is equal to e to the minus y. And we have y0 is 0. And we have the analytic solution, y of x is natural log x plus 1. Don't ask me how they got that. We're on an interval of 0 to 1/2, and we're using an h of 1/10. Okay, and back to number. It looks good. So we want, here we go, boom. Hit there, exponential minus e to the minus y. E to the minus y. Real answer, natural log 0 plus 1, natural log of 1 is 0. And now we're getting, we're pretty close there to the real answer too. And I did it all the way out to 1, although I didn't need to. But it does go out to 1. Okay, so that ends the problems we're working in section 2-5. When we do the 2-6 ones, we will go and compare our answers between each of those problems because it's the same problems we're solving each time.